Okay, last lesson. So, dot product and angle between vectors. That first formula in that first text box is called the dot product formula. You'll need to memorize it for your test this Thursday. Now, if it says that if vector u is in component form with x1, y1, and vector v is in component form with x2, y2, then the product of vector u times vector v is just x1 times x2 plus y1 times y2. And you'll need to memorize that formula. And again, this is called the dot product, because what is this? Well, first of all, what does that symbol look like? It looks like a dot. So this is more physics, and in the science world, they're pretty straightforward, because here, well, it looks like a dot, so they call it the dot product. So it's pretty self-explanatory. So it's called the dot product. And I said, note the dot product is a scalar. And that's because we have a number times a number plus a number times a number, and our answer will be a number or a scalar. So number one, we're actually going to use the formula. So for number one, it says that vector u is 3, negative 6 in component form, and vector v is 4, negative 2, also in component form. We need to find the dot product. So we need to find vector u times vector v. So the formula that you'll have to memorize. So for the dot product, it's x1 times x2 plus y1 times y2. Now, it's helpful if you label. So your first vector is x1, y1. Your second vector is x2, y2. So if you label things, you're less likely to make mistakes. You can see where every value needs to go. So let's go ahead and substitute in some values. So vector u times vector v is equal to, what do I put for x1 and x2? 3 and 4. So we need to do 3 times 4 plus, now we need to do y1 times y2. So what do I put for y1? Negative 6. What do I put for y2? Negative 2. So our dot product is equal to 3 times 4 is 12, and negative 6 times negative 2 is 12, and 12 plus 12 is 24. I started putting a plus sign there. That's wrong. 12 plus 12 is equal to 24. So again, notice with dot product, your answer is going to be a numeric value or scalar. So that's how you compute the dot product. Make sure you memorize that formula. You will not have a formula chart on your Unit 9 test. Now, if you're asked to find the angle between two vectors, the formula you'll need to also memorize is cosine of theta, and theta is your angle between the two vectors, is equal to, looking at the numerator right here, what is this thing called? What is that thing? Dot product. This is called the dot product. So in the numerator, you have the dot product, and in the denominator, you're going to multiply the two magnitudes of the two vectors. So dot product in the numerator, and product of the magnitudes in the denominator. Now, what's another way I could write the dot product?
X1, X2, so Y1, Y2.
Yeah, x1, x2 plus y1, y2 divided by the product of the magnitude. So that's another way you could write it if you wanted to, but it's just the dot product in the numerator, and in the denominator we multiply the two magnitudes. Okay, so problem number 2, it says to find the angle between vector u is at 6, 4 in component form, and vector v is at negative 7, 2 in component form. So again, if you're trying to find the angle between two vectors, This is the formula we'll be using in just a moment after we draw our diagram. So diagram it first. So draw vector U. If it's in component form, that means the tail is at the origin. And our tip is at 6, 4. And here is vector U. Now vector V is also in component form, so its tail is also at the origin, but its tip is going to be in quadrant 2 at -7, 2. And this is vector V. And they asked us to find the angle between those two vectors. So the angle between the two vectors, I'm going to call that angle theta. Just to make sure it matches with our formula. So we need to find that angle between. And to find the angle between, use that formula in the text box, which is cosine of theta is equal to the dot product divided by the product of the magnitude. Now again, for our dot product, we said you could just do x1, x2 plus y1 times y2. Let's just go ahead and switch these to formulas. And what's the formula for magnitude? Square root of x squared plus y squared. So now let's switch over to formulas. Now you're supposed to have already memorized the magnitude formula, the square root of x squared plus y squared, if your vector is in component form. Okay, so let the math fun begin. Now what I would do is I would go ahead and label my vectors. So the first vector, vector U, is x1, y1. Vector V, label it x2, y2. Now from here, it's just putting the numbers in. What do I put for x1? 6. What do I put for x2? -7. What do I put for y1? 4. And what do I put for y2? 2. Now multiply the magnitude. So the first one is going to be for vector U. So for vector U, what is the x value? So this needs to be 6 squared plus, and for vector U, what is the y value? 4. So 6 squared plus 4 squared. And that needs to be multiplied by the magnitude of vector U. We already did vector U. This needs to be vector V. So for vector V, what is the x value? -7 squared. And what is the y value for vector V? 2. So 2 squared. Now, let's do a little bit of simplifying. What's 6 times -7? And what's -42 plus 8? -34 for the numerator. And in the denominator, what's 36 plus 16? 52. So square root 52. And this would be 49 plus 4. What's 49 plus 4? 53. Now, this is an arc cosine value. We want theta to be in degrees, so make sure your calculator is in degree mode. And since this is an arc cosine value, make sure you do second cosine. Now, for the 84, you'll have to make sure you group that denominator in parentheses. So second cosine. And inside the parentheses, you put the -34, and then the division symbol. Now the denominator has to be in parentheses. So after the division sign, you need to open up a parenthesis. and square root of 52 times square root of 53. Close the parenthesis, close the parenthesis. And we're going to round to the nearest whole degree. So what is theta to the nearest whole degree? 130. You should have gotten approximately 130.3. So theta is approximately 130 degrees. Now I can go back to my diagram and check it. So theta, here's theta right here. Does it look like that entire angle is about 130 degrees? Does that look legitimate? Yes, it does. You can go back and look at your diagram to see if it looks reasonable. Okay, yet another formula you need to memorize is for parallel vectors. But before we memorize and discover the formula for parallel vectors, let's talk about parallel lines first. So it says if two lines are parallel, then what is true? What are equal? The slope. So if two lines are parallel, then their slopes are equal. So we are going to take that thought and transfer that knowledge to parallel vectors. So right below that, it says a similar relationship exists between parallel vectors. And in that text box, you need to memorize this formula right here. And it says for two vectors, vector u is in component form x1, y1. Vector v is also in component form x2, y2. If y1 over x1, which are these two values right here, so y1 over x1 is equal to y2 over x2, then the vectors are parallel. So if the ratio of y over x are equal for both vectors, that means they are parallel. So if the ratio of y over x are the same for both vectors, then yes, they are parallel. So number 3, it says to find the variable a for vector u in component form is 3, -6, and vector v in component form is 4a. So we're solving for this value a, such that vector u is parallel to vector v. Now, in order for these two vectors to be parallel, that means the ratio of y1 over x1 has to equal y2 over x2. Now, again, it's helpful if you label your vectors. So the first vector needs to be x1, y1. Second vector has to be x2, y2. And if you have everything labeled, then you just substitute your numbers in. So what do I put for y1? -6. What do I put for x1? 3. And for them to be parallel, these ratios have to be equal. And what do I put for y2? A. That's what we're solving for. And what do I put for x2? 4. So solve your proportion by cross multiplying. So if I multiply this diagonal, that gives me 3a. If I multiply this diagonal, -6 times 4, -24. And divide both sides by 3. And what is the value for a? -8. So again, memorize that formula. If the vectors are parallel, then y1 over x1 is equal to y2 over x2. Okay, perpendicular vectors. If vector u and vector v are perpendicular, then what's the angle between them? Parallel lines form to meet what kind of angle? 90 degrees. So if vector u and vector v are perpendicular, then the angle between those vectors is 90 degrees. Now let me draw a picture over here. Down here is vector u, over here is vector v, and if they are perpendicular, then the angle between the two vectors has to be 90 degrees. Now, before we find this formula right here, we're going to discover where it came from. Okay, so if we're talking about the angle between the vectors, we have a formula we just found for that. And that formula was cosine of theta is equal to the dot product divided by the product of the magnitude. Now we're going to fill in what we know. Now theta is the angle between the vectors. And looking at these two vectors, what angle is between those two perpendicular vectors? 90 degrees. So instead of theta, I'm going to change this to 90 degrees. So this would be cosine of 90 degrees is equal to the dot product divided by the product of the magnitude. And from my unit circle, what is the cosine of 90 degrees? 0. So this is equal to 0, which is equal to the dot product divided by the product of the magnitude. And the opposite of dividing by the product of the magnitude would be to do what operation? I can then multiply both sides by the product of the magnitude. So whatever I do to the right side, I'll also have to do over here to the left side. And when I multiply the left side, what does that give me? When I multiply these three, it gives me 0, which is equal to the dot product of the two vectors. And that is the formula that's inside your text box. So this is the last formula you'll have to memorize. And two vectors are perpendicular if their dot product equals what? 0. So if the dot product is equal to 0, then the two vectors are perpendicular. And as a reminder, how do you find the dot product? x1 times x2 plus y1 times y2. So just as a reminder. Okay, so now let's do number 4. Says to find the variable a for vector u is 3, -6, and vector v is 4a, both of those vectors in component form. And we want vector u to be perpendicular to vector v. So in order for those vectors to be perpendicular, that means their dot product has to equal what? 0. And the formula for dot product that you also need to memorize is x1 times x2 plus y1 times y2. And make sure you label your vectors. So the first vector is x1, y1. Second vector is x2, y2. What do I put for x1, x2? 3 and 4. So 3 times 4. Plus, what do I put for y1 and y2? -6 and a. Solve that equation for a. So 3 times 4 is 12, and -6 times a, -6a. Solve for a. So we need to subtract 12 to both sides. And that gives me -6a is equal to -12. Divide both sides by -6. And the value for a that will make those two vectors perpendicular would be 2. So a equals 2. Next one, number 5. Number 5 is to determine if vector u and vector v are parallel, perpendicular, or neither. So let's start with parallel. If they are parallel, that means the ratio of y1 over x1 is equal to y2 over x2. If they are parallel, those ratios are the same. So again, label your vectors. So vector u, label it x1, y1. Vector v, label it x2, y2. What do I put for y1? -4. What do I put for x1? 3. What do I put for y2? 3. And what do I put for x2? 4. Are these ratios the same? No, they are not. So that means they are not parallel. So if they're not parallel, see if they are perpendicular. And two vectors are perpendicular if their dot product equals what? 0. And how do you find dot product? x1 times x2 plus y1 times y2. So what do I put for x1 and x2? 3 and 4. It won't always be 3 and 4 at this point, incidental so far. And what do I put for y1 and y2? -4 and 3. 3 times 4 is 12, and -4 times 3, -12. Do those two numbers add to 0? Yes. So that means our answer would be perpendicular. You can write out the word perpendicular, or you can just put the symbol. Now, if it were not parallel and if it were not perpendicular, then your answer would be neither. We don't have a formula for neither. But if it's not parallel and it's not perpendicular, then it has to be neither. Last one, number 6. Given point A is at 3, 6, point B is at 7, -5, and point C is at -4, -3, find the measure of angle A. So in order to know what they're talking about, first thing we have to do is draw ourselves a diagram. So plot those 3 points. So point A is at 3, 6. Point B is at 7, -5. Point C is at -4, -3.
That's awesome.
Mm-hmm.
Those you don't have to change them to brackets.
No. No, you don't have to get these in component form.
Oh.
Or actually, yes, we will here in a moment. But not yet. Not yet. But we will. Okay, so we're looking for the measure of angle A. So in order to have angle A, I need to have a ray from A to B, and another ray from A to C, and those 2 rays are actually vectors. And if we're looking for the measure of angle A, we're actually looking for the angle theta that is between 2 vectors. And we have a formula for that. If you recall that second formula, if you're looking for the angle between 2 vectors, it's the cosine of theta is equal to the dot product divided by the product of the magnitude. Now, if you notice, vector u and vector v have to be in what form? Component form. So yes, in order to use that formula, we will have to get them in component form. So first step, find the component form. What does it mean for component form? That means the tail is where? At the origin. So let's say point A was the origin. If I'm trying to get to, well, first of all, we need to know which one is vector u, which one is vector v. It doesn't matter. I'll just say the one on the left is vector u, the one on the right is vector v. You could have switched it, you'll get the same answer in the end. So if I'm trying to find a component form for vector u, that means this point should be at the origin, which would be 0, 0. But it's not at the origin. But if this were the origin, how many do we have to go to the left to get to point C? -7. And how many do we have to go down? 9. So -7, -9. And then for vector v, again, if point A is at the origin, how many would we have to go to the right? 4. So that would be positive if you're going to the right. And how many would we have to go down? -11. So if you're going down, that has to be negative. Now that we have component form, now we can use the formula for the angle between two vectors, which would be cosine of theta is equal to the dot product divided by the product of the magnitude. And let's switch over to formulas. How do you find dot product? X1 times X2 plus Y1 times Y2. And the formula for magnitude is the square root of X squared plus Y squared. And the next thing we need to do is label these vectors. So the first vector is X1, Y1. Second vector is X2, Y2. What do I put for X1 and X2? -7 and 4. What do I put for Y1 and Y2? -9 and -11. Now for vector U, what do we put for X? -7 needs to be squared. And what do we put for the Y value of vector U? -9 needs to be squared. And now for vector V, what is the X value of vector V? So that would be 4 squared plus, what do I put for the Y value for vector V? -11 needs to be squared. So that gives us cosine of theta is equal to, what's -28 plus 99? 71. And what's 49 plus 81? 130. And what is 16 plus 121? 137. Now this is an arc cosine value, so make sure you do second cosine, and also make sure you group the denominator in parentheses. And we'll round to the nearest whole degree. So second cosine, then we have 71, divide by, then in the parentheses, square root of 130 times square root of 137. Close both parentheses. And I got 57.85809017. So 57.858 rounds to what? 58 degrees. So the angle, or the measure of angle A, is 58 degrees. And I could go back to my diagram, and does it look like this angle is about 58 degrees? Yes. Yes, it does.